So if we have a variable cam timing problem, then we know that it's a breathing problem. All drivability faults fall into three categories. They're either breathing, fueling, or ignition. We just talked about that we can use fuel trims to help diagnose and confirm variable cam timing problems on V engines with overhead cams, single or double overhead cam systems. The other thing that's going to happen is it is a breathing fault. We're trying to confirm that we have a variable cam timing fault, therefore we're going to have a breathing problem. My two favorite tests for breathing problem is one, to graph the manifold absolute pressure sensor over time on your scan tool. Now when you hook up your scan tool, as we're going to do here, you're going to see that you have options as English or metric. Well, if you look at inches of mercury, which are typically 0 to 30, versus metric kilopascals, which 1 atmospheric pressure would be 0 to 100, you're better off to increase your resolution by looking at kilopascals. So when you graph the map sensor over time, you want to graph it in kilopascals, and you want a steady map sensor. Typically, engines that don't have problems have good breathing characteristics. If we were using a vacuum gauge, we'll fall between 18 and 21 inches of vacuum. In kilopascals, somewhere between 30 and 40 kilopascals is a good range. But what you're really looking for is that it's not too low, or not too low a vacuum, or the kilopascals are too high, or you're looking at that it's rapidly changing, which would indicate a valve train problem. Most of the time when variable cam timing systems fail or they advance at idle, you have lower vacuum. And the lower vacuum is going to show up with a steady but higher kilopascals or a lower engine vacuum. The other thing we want to do to confirm a breathing problem is a volumetric efficiency test. In a volumetric efficiency test, we're going to look at mass airflow, RPM, and incoming air temperature on the scan tool. We're going to plug that into a volumetric efficiency calculator, and we're hoping that our VE number is greater than 80%. Well, I just said we're going to look at mass airflow in grams of air per second. What if we don't have a mass airflow sensor? In every vehicle I've ever seen in my career, even though I didn't have a mass airflow sensor, I had a data PID called load, calculated load, Hyundai Kia call it relative charge, or just load percentage. Personally, if I go out and I floor the vehicle, I want any of those PIDs, load, relative charge, load percentage, I want those to go above 90%. If I'm plugging into a VE calculator, I want them to go over 80%. So not passing a breathing volumetric efficiency or a load PID can be confirmation to a variable cam timing problem.